Hi there and welcome to Oismus Games. Today we're gonna learn how to make head orientation depending on the slope the player is working on. Let's go. So first let's see what we're going to build. As we go down this slope, you can see that the head slightly goes down. When we go back onto the plane, the head rotation goes back to normal. And when we go down onto another slope, the head goes down again. So it's as simple as that. Now let's see how we're going to do that. First, let's create a new character class. It will be based on the third person character. And we're going to call it BP head orientation slope character. So we're going to create a new variable called current slope. It will store the current slope we're working on. Now let's create a getter function for this variable. To return float, which is the current slope. We're simply going to return this, and we're going to make this function a per function so that we can use it without using the exec node. Now we can create the main function, which is the update slope, or rather update current slope, and we're going to call this function on tick so that we can compute the current slope at each tick. First, we want to make sure that we are touching the ground, because we don't want our head to rotate when we are in the air. So we're going to take our character movement component and check if we are falling. And if we are not falling, oh no, not this one. If we are not falling, we can continue. Otherwise, we will return a value of 1. We will see that a little bit later. So what we can do there is to make a first line trace by channel. And this first line trace will go straight from the center of the character down to the ground in a straight line. So we're going to start at the character location, which is the actor location, and we're going to use the actor up vector, and we're going to add this actor up vector multiply by a value so that we will hit the ground, so the value needs to be high enough for that. So we're going to convert this pin to a float, and we're going to multiply it, let's say by let's try minus 150. So it's minus because we want the line trace to go down, and originally the up vector points upward, as the name says. So we can put that in the end node, and that's it for the first line trace. So just to be sure, we can go to our third person game mode. This is the one that is used by default, and we can go to the default pawn class and use our newly created blueprint class. And if we start the game, we should use our character class. We're just going to use Mani because we're then going to use the anim blueprint from Mani also, and we just want to draw debug so that we can see the line trace. We just need to go to the event graph and goes to the tick and call our update current slope function. So if we start the game, you can see the line trace that is done at each tick. So it's persistent, so it's going to stay on screen, but that's what we want, so it's working fine. Now we can continue. So we're going to continue only if the first line trace has it, otherwise the second one will be useless. And we're also going to break our hit. And take the location of the impact, so this one, and promote it to a local variable that will be only available inside this function. And let's say we're going to call it hit location 1 to store the location of the first hit. It's only to make it easily accessible, because we could use it directly from there each time, but the function will be a little bit large, so it's better to use a local function. It will be more clear. So now we can do the second line trace. We will use the same function, the line trace by channel. So for the second trace, what we are going to do is to do the same trace as the first one, but we're going to do it a little bit forward, following the forward vector of the character, so following the y-axis in this case. Just to explain it a little bit better, let's take this simple schema. So this is going to be the slope where our character is working on. Let's say that our character is going to be this star there, so let's have a little bit of an imagination. Let's put it red. So the first line trace that we are going to do is going to go from the center of the character and straight down there like that. And the second one that we're going to do is going to be a little bit forward like that. And let's say that our character is moving in this direction there. Let's say that he's moving toward there. The first one will hit at this point there, and the second one will hit this point over there. So what we're going to use to compute the slope is the angle between this point and this point. So this is the plane. Let's put it in green like that. It's 3D beautiful. That's not the point. So the angle that we're going to use is this angle over there. This is going to be the slope. So it's not really high res, but this is the angle that we're going to compute. For that, we're going to compute the rotation, the look-at rotation between this point and this point. And we'll use the pitch of this rotation to get the angle. Let's go back to our function, and the start location will be the actor location, same as the previous one. And I forgot to say, but we are going to make our second trace depending on the velocity of the character. So given that our character is moving toward there, we trace forward following this direction there. It's going to be more clear when we're going to see the two traces at the same time. But trust me at this point, and maybe you will understand this a little bit better later on. So we're going to take the velocity of the character and we're going to normalize it to get only the unit vector without any length, and we're going to multiply it by a small amount. Let's say single float is fine. Let's say by 5, because we just want to trace a little bit forward, not too much. and we're going to add this one to the actor location, and we're going to split this value because we want the X and the Y from this, but the Z location we still want to keep the one from the actor location. So let's break this vector, and we're going to combine the both of them to make a new one. So we are going to keep the X and the Y from the velocity and the Z from the actor location, and this is going to be our start position, and the end position will be the same as the first trace. We're just going to take the same logic, those 3 nodes there. Let's put it a little bit there, and we're going to take the start position and add it to the actor up vector multiplied by minus 150, so that we trace straight down. And let's put that at the end. So let's put it at persistent also, just to see how it looks. And let's change the color so that it is more visible. Let's choose let's choose pink. Pink is fine, and this one doesn't really matter. Actually, let's draw only for one frame for the both of them. It will be more clear. Let's see. So there, you can see the pink one is always a little bit forward, the red one, following the velocity of the character. When we are not moving, they are the same. They are hitting at the same place. So now let's use those 2 traces to compute the slope. It's going to be as simple as using the location of the second hit, and we're going to use the find look at rotation, and we're going to take the first hit location as the start and the second one as the target, and we can break this find look at rotation, and we're going to use the pitch. The pitch is going to be the slope, so we can set the current slope to this value there. So to make it a little bit more obvious, we can just for the explanation make a new line trace by channel, and we're going to unsplit or combine rather the spin, and we're just going to make a line trace using this rotation just to show the direction of this rotation. For that we're going to use the actor location, and it's going to be the start, and we're going to add this, but we're going to use the forward vector and multiply it by a float or an integer. It's about the same. Let's say 200 is fine, and we can put that at the end. Let's just disable the debug trace for those 2, and for this one let's say for duration, no, for 1 frame, and let's see how it looks like. So when we're working on a plane, it's go straight forward, but as soon as we work on the slope, you can see that the trace is following the slope. So this is why we are using this rotation, and the pitch angle is the one that that is following the slope. The other two values are no use for us. So this is why we are using this value. So we can delete that and split this and use the pitch. So we've got our slope. So now we just need to undo the case when we are falling or when one of the trace does not hit. And actually I've forgotten to add a branch there to handle the case when we do not hit. And all of those cases we will set our current slope to 1 so that the head does not rotate when we are in the air or where there is no hit. So we're going to use this node for this case also. Let's create this one. So now we've got our slope that we are updating at each tick. We could use a timer to reduce the amount of computation, but it can result in some stuttering in the head rotation, so it's better to do it on tick, and it's not too heavy on the performance, so it's fine. Now we just need to create a new animation blueprint to use this current slope and use it to rotate the head. So for that we're going to use the animation blueprint from Kin, which is from Mani rather, because Kin is overriding the one from Mani, so it will be easier with this one. Let's go back there and copy it there. Let's rename it to add orientation slope. So to get the slope, we just need to change this cast over there, and we want to cast the character to a BP head orientation slope character. This is the blueprint that we have just created there. And we can change our character variable to this class, which is this one. So we can change the type safely because the head orientation character inherits from the character class. Oh, I've made a mistake. It's not. This one is the animation blueprint. This is the one that we want to cast to. There. So we can remove this one. Let's put that a little bit backward. And there we go. So now we can make a new pin and a new reroute node. And now we can take our character there. So first we will use the speed of the character. So let's take the velocity, because we don't want to rotate the head of the character when he is not moving. So that's why we want to get the speed. And to get the speed, we want only the speed from the X and Y axis. We don't care if the character is moving following the Z axis. So for that we're going to use the vector length XY node, and there we can promote a new variable and call it speed. So now we can compute the current slope. We're going to use the one that we have computed in the blueprint, but we're going to make some slight adjustments. First, we want our character to orient its head in a smooth way. So for that, we're going to use an F-interp node the return value is the one that we're going to promote as the variable that we're going to use in our animation. So for the enter speed, it's a little bit by taste and depending on the result that you want. I found that 5 is fine by default, but you can tweak it as you want. For the delta time, we're going to use the delta time x from there. So the current value will not be this one, but this variable there. They have the same name, but they're not the same. We're going to use the one from our animation blueprint. And for the target, we could use directly this one, but what we want to do is to prevent the head from rotating when the character is moving upward on a slope with a positive angle, because we don't want our character to rotate its head when it's moving on an upward slope. So for that, we're going to take that and check if we are greater or equal to 0. There we're going to use a select float node, so that we are going to take the value of the current slope only if the value is less than 0, because if the value is above 0, it means that we are working on an upward slope, and in that case we don't want to rotate the head. So if we are at A, that means that the slope is greater than 0, we keep 0 as a value. But if the current slope is lesser than 0, we are going to take the absolute value from the slope, so that we're going to take the positive value, and we're going to use that as the target value. So now we've got the value of our current slope, and this one is always going to be positive. So now that we've got our value sets, let's put a comment. And let's go to the anim graph so that we can use those two values. So the node that we're going to use is the transform born. To use it, we need to switch to component space using this transition, and then we're going to go back to local space, and in between we're going to modify our head rotation. So the node will be the transform born node. So we first need to choose the born that we are going to modify. If we go onto the skeleton, you can see that the one that we want to modify is this one, the neck 2, so that our head will rotate like so. So let's choose this one. And the one that we're going to modify is the rotation X, the roll, because as you can see there, the one that we've touched is this one. And if we go to the coordinate of this bone, you can see that it's the one following this axis, and this one is the X. So we're going to take our current slope and feed it in this node, this pane rather. And you can see as we compile, it's telling us that we need to choose the component to modify. All this one are put as ignore. So we want to modify the rotation, and we want to add to the existing rotation and not replace it. So we're going to choose this one. And this should be enough. We just need to go back to our blueprint and select the mesh of our character and choose the animation blueprints that we have just created. It is this one. And now let's see what we've got. So as we go up, nothing happens, and when we go down, the head rotates. So it's very light, as you can see. but it's working fine. If you want to have a greater rotation when we go down the slope, we can go back to our event graph, and there we can take the current value that is computed in the character blueprint and multiply it by a factor greater than 1, so that we can control, we can increase or decrease how much the edge rotates. So for example, let's say that we want to rotate it a little bit more. So we're going to multiply it by 1.5. And if we go back into the game, you can see now that the head rotates a little bit more compared to before. And yeah, that's it. It's working fine. So that's it for this tutorial. Thank you for watching. Like always, you can thumbs up, subscribe and share if you enjoy the content. And that's it for this video. So see you another time. Bye.